So yesterday we started exponents. We talked about the little number up there is the exponent. This is the base. We talked about the difference between expanded form and exponential form. We discussed how to figure out the negatives, a negative base. If it has parentheses, you keep it in parentheses. If not, you write it out this way. Cecilia and Aiden, are those your seats?
Yeah.
Yeah.
Taylor, okay, so I may have to move either Aiden or Cecilia.
I see Taylor sits there.
Okay, that explains it.
Just here for now,
Alright, multiplying and dividing.
so I don't fall asleep on the wall.
If the bases are the same and we're multiplying, we add the exponents. Bases are the same and we're multiplying, we add the exponents. Dividing, if we're dividing, we subtract the exponents if the bases are the same. Don't forget to make sure that you keep this negative there. For example, right here, common mistake. Kids want to leave off one of those negatives. You got to make sure you always have a negative there. So, always. So that if you have a situation like this, it becomes a plus. If you have an exponent inside and on the outside, you multiply them. We talked about if the exponent's 0, then the answer is always 1. Negative exponents. You can't have negative exponent. Got to turn it into a fraction and put it on the bottom as a denominator. If it's already on the bottom as a denominator, moving on up to make it positive. Here's another example. Exponent on the inside and outside, we multiply, get negative 8, we brought it on the bottom, and we simplified. Here's more examples. You can look back in your notes. This was the last example we did. We put the negative on the bottom. This one was positive. It stayed on top. All right. Now it's time for examples. So go ahead and open up your book to page 36. Let's see. Okay. All right. Let's go ahead and get started. Number 1. Michael, read the directions.
Write using repeated factors, then a value.
Basically, they're saying write an expanded form and then give the answer. So number 1 is 4 to the power 3. So Michael, what is it in expanded form?
4 times 4 times 4.
And then evaluate, meaning solve, give the answer. I'll let you figure that out.
Keyboard.
Yep. Good job. All right, Michaela, number 3. It's negative 3 to the power of 5. How would I write that in expanded form?
Do parentheses negative 3 times negative 3 times negative 3 times negative 3. Oh, wait, like 5 times.
Very good. And I'll give you a minute. See if you can come up with the answer.
Multiply two negatives is
Positive. Y'all should be trying to figure it out too.
Is it negative 243?
Yes, ma'am. Negative 243. Good job. All right, 5. Gabby. 2,314 to the 0 power. Yes. Some of y'all are like, man, why didn't I get that one?
Yeah.
All right, very good. 7, Emily. Emily's like, why didn't I get that one? 4 to the negative 2. Oh, no. Are we allowed to have a negative exponent, Emily? She's shaking her head no, you two people. Okay, so how do I make this positive? Move it. Where?
Down?
Okay, move it down. Yeah. And as my 7th graders have already figured out, they're like, yeah, you kind of turn it into a fraction. And you put it in the denominator. So yes. So then it becomes 4 to the power 2, and that's in the denominator. Now, write it in expanded form. And this is where 7th grade messed up, but y'all did too last year. How do I write this in expanded form, like up here? Does that go on the top or bottom? Yes, it stays on the bottom. Because it's a denominator now. So it needs to stay on the bottom. Good job. And what is 4 times 4, Emily?
16.
There you go. Good job. Any questions so far? All right, number 9. Taylor. Negative 2 to the power of negative 4.
Alright, put it under 1.
Okay, and so what is under 1?
Negative 2 to the power of 4 over 1. What, under 1?
Okay, so why do we keep this negative sign but get rid of this one?
Because exponents can't be negative, but the number can.
Bingo. Guys, notice, you can't have a negative exponent, so we put it under 1, turned it to a fraction, and made it positive. But guys, don't mess up. This negative goes with the base. You absolutely can have a negative base. So just because you put it under 1 doesn't mean that becomes positive. It stays negative. Very good. So be careful. That's a common mistake, as you can imagine. Okay, so Taylor, how is this written out? And it all stays under 1 still.
So it's parentheses 2 times 2 times 2 times 2 with a negative on the outside.
Excellente. Because now Michaela's had parentheses with her negative base. So the parentheses stayed with it. Taylor's did not. So he's correct. You write all the 2's inside the parentheses and 1 lone negative on the outside. So Taylor, what answer do you get?
1 over negative 16.
There you go. That can also be just negative 1 over 16. Either one. The negative goes with the whole fraction. Good job.
We went through it twice.
Because you can have the negative right there. It can go with that. So Good job.
Thank you.
All right, Wit. 1 over -3 to the power of -4.
You would take it out of the fraction and do -3 to the power of 4.
Very good. -3 to the power of +4. That's right. So you lost the negative on the exponent, became positive, but the base negative stays the same. Now, how do I write that in expanded form and solve?
You would put a negative on the outside of the parentheses and then 3 times 3.
Are you sure? Look, this is Taylor's. No parentheses, and it was written like this.
Oh, well.
Look, this is Michaela's, and written like this.
Oh, then you would do -3 in parentheses 4 times.
There you go. See, I told y'all those negatives are ridiculous.
Yeah.
Okay, and so when you solve it and get an answer, you let me know. The rest of you are supposed to be solving it too.
It would be positive 81.
You're correct. Positive 81. Good job, Whit. All right, 13. Aiden. So this one says simplify, leaving each answer in exponential form. Are they wanting you to solve it like up here?
No.
No, they're saying, hey, don't worry about solving this time. Just leave it in exponential form. So 13, 3 squared times 3 cubed. So what would I do here? Unlike Gabby, do you have to solve all of this out? Or can you use a trick?
A trick.
What trick would that be?
You add the exponent
Why are you adding the exponents?
because you're multiplying.
Not just that, because you're multiplying and
Oh, the same number.
bases are the same. Absolutely. If the bases are the same and you're multiplying them, then you can't, he's correct, you would add the exponents. So 2 plus 3 is what, Aiden?
5.
So your answer is just 3 to the 5th power, and they said in the directions to leave it in exponential form so you don't have to do any more. Any questions? Cecilia. Number 15. 8 to the 3rd power raised to the 5th power. How do I solve that, Cecilia?
You're at 2 and 5.
2 and 5?
3 and 5.
You're adding them?
Yeah.
Why?
There's anything next to a what's it called? It's being multiplied.
So you add the exponents? Look in your notes. When you have an exponent on the inside of parentheses and the outside.
Because the one on the outside is saying everything in here is raised to the 5th power.
That's right.
What temperature is good to
Oh,
know?
times 5.
Yeah, man. So 8, when the exponents are like that, you multiply them. Good job. And Cecilia, what is 3 times 5? You are correctamundo. Good job. See, this is why we take notes, so you can go back and look at them just in case. Trust me, even though I teach the same junk year after year, I told y'all that I have that short-term, long-term memory issue. I have to sometimes look back too. I have to tell y'all real quick, see, story. So Allie has started college classes, and she's gonna kill me for talking about this. But she's used to how easy things got for her, even with Dr. Gap. Once you fit, your sister will tell you, once you figure out Dr. Gap and you're used to paying attention in class and studying and everything, it starts getting easier. Okay? Well, things her last year especially got real easy. Now she's in college. She has one professor who barely speaks English and she doesn't understand him. Okay? Too bad. You know, you're not in school here anymore where, you know, it's just hard, you know. She has another professor that she has emailed 100 times. He won't reply. Nothing. So she's figuring out the hard way what college life is really like. She's got some that she likes. So last night she was doing homework because she took a quiz. And he said it's just going to be an easy quiz. This is her calculus class over the syllabus. That means like what Senora Smith used to do. You know, like here's like our rules and stuff like that. I'm going to give you a quiz over the rules. Well, he decided to change it at the last minute. So yesterday she took a quiz and she came in freaking out. They're allowed to take it 3 times. You have 3 times to like attempts. And she made an 85. She's freaking out over the 85 because she's got to maintain like an A average to be, you know, to stay in the engineering school. So she's freaking out, and I said, hey, do you have homework in calculus? Yes. When's it due? I don't know, like next week or something like that. I said, do you think you should start it? Yes. The 2 of us were up late last night. She comes running in. She could do the calculus. She couldn't remember. Don't write this down. She forgot this. Remember that? And so last night she comes running in and she's like, help me on these problems. Help me on these problems. I keep getting them wrong. And I said, okay, hold on. I had to refresh my memory to go back to apply it to her calculus class. And she's fine now, but that tells you right there, even I had to look this stuff up. But all this stuff right here, you're going to see in college. Okay? One of the things she told me, I wish I kept my textbooks.
I keep all my textbooks.
And I said, what? And she goes, I wish I kept my math textbooks. And she said, I could have very easily flipped back. And I said, well, you know, you've got Google. That you can Google, you know, this stuff too, and it has an explanation. She goes, yeah, but the textbooks in Algebra 1 and Algebra 2, way easier. And I said, okay. So if you want to, I would start keeping Algebra 1, Algebra 2 textbooks for future reference, just in case. Taylor?
I've kept all my books in 2nd grade.
There you go. Good job.
They're all just in my room.
Oh, goodness. Okay, you don't have to keep all of them. That's like a hoarding issue. All right. Like, you know, spelling books. You really need that?
We didn't have a spelling book, did we?
Yes.
You said all your books, so.
Well, then I probably have it in there somewhere.
Dude, why your spelling book?
Yeah, it's just
Okay, here we go. Let's see. Going back to the front, Michael,
Yes, that's me.
number 17.
Number 15.
How do we do that?
You multiply?
What are we multiplying?
Oh wait. No, you add it.
What am I adding?
2 plus -7.
Why?
Because they're the same base.
They have the same base and
The 2 is first.
no. and we're multiplying.
Yeah.
So then you add the exponents. Very good. And what do you get?
Total to the power of -5.
Can I have a -5?
No.
What do you need to do?
Put the whole number underneath the 5. I mean the 1.
That's right. And it becomes positive. Very good. All right, any questions so far? Number 19, Michaela. I have 10 to the power 12 times 10 to the power 3.
The bases are the same when we're multiplying, so we're going to add 12 and 3.
Very good. The bases are the same. We're multiplying, so you add the exponents. And what do you get?
15.
That's right. Good job. Gabby, you have 1 over 3 to the second power times 1 over 3 to the third power.
You add the exponents.
Why? That's right. We're multiplying. The bases are the same, so we're going to add them. And what do you get? Under 1, because that can be confusing. 7th grade had trouble with that. Very good. Emily, 23. I have 1. Oh, this is a good one. Why do you keep getting the hard ones?
I don't
1
know. You tell me.
over 9 to the second power divided by 1 over 9 to the fourth power.
Can I do?
No, it says Emily's problem. So Emily, what do I do? What are we subtracting? Why?
Because you're dividing.
Because we're dividing and the bases are,
The same.
that's right, so she's correct, we're subtracting. They stay under the 1 for right now. So I have 9 to the power 2 minus 4. And what do you get? So 1 over 9 to the power of -2. Oh no, can I have a negative? So how do I fix that? Put it back on top and it becomes positive. Very good. Any questions? All right. Wet, 25. Seven to the -2 power divided by 7 to the 9th power. How do I solve this?
You're going to subtract 9 and 7.
What?
Or 2 and 9.
Okay. Why are you subtracting?
Because you're dividing.
And the bases are
The same.
okay. So it's written, boys and girls, as 7 -2 minus 9. So what do I get?
7.
7 to the power of,
7.
really? -2 and -9.
Oh, -11.
Very good. Can I have a -11?
You can't.
So what do I do?
You put it under 1.
Very good. And it becomes positive. Good job. Taylor, 29. 28 to the power of -4 raised to the power of -2.
So it's 28 to the power of -4 times -2.
Okay, you're multiplying -4 and -2 because it's on the inside and outside. So -4 times -2, and what do you get?
28 power of 8.
Very good, +8. Aiden, 31. 2 to the power of 3 divided by 2.
You would subtract 3 minus 0.
3 minus 0? Why?
Because there's no exponent.
Oh, if there's no exponent, we assume what is there?
A 1.
1. Very good. I purposely, see, that's why we do so many examples. Okay, or examples, not samples. Okay, so if there's no exponent, we put in a 1. Now tell me what to do.
Then you do 3 minus 1.
3 minus 1. Because the bases are the same and we're dividing. And so that gives you what?
2.
2 to the power of 2.
22 goes.
Alright, I'm going to just do 2 examples real quick. Y'all need to write these down. What if I had 2/3 to the power of 3? Anyone want to tell me how to write that in expanded form? Gabby?
2/3 times 2/3 times 2/3.
Bingo. And then you would multiply across. That would be, what would that be?
Who? Always.
Anyone, first person. Raise your hand. Gabby? Yep.
Should also be 2 components in those cases.
So if you have a fraction with an exponent, that's how you work it out. What if I had another example? Last one. 3/4 to the power of -3. Oh, this is good. Who wants to guess on how to do that? Taylor?
So, let's say, right down.
And y'all need to pay attention because it goes against a lot of what we've talked about.
So you flip it around, this is the fraction.
And so what do you get?
So you get 4/3 times 4/3 times 4/3.
Perfect. Look, if you have a negative exponent, all you have to do is flip this and then solve.
Wait,
It would be like this.
is it just for a fraction?
Yep, just for a fraction. Make sure you write that down. If you have a fraction and a negative exponent, you flip it and then you can write it out. Any questions?
Can you say that one more time? If you have a fraction and
Look right here. If you have a fraction and a negative exponent, you flip it and then solve it. Word. Let me go find that kid. All right, any questions?
Was he laughing because he thought we had the two?
All right, so you're doing page
007.
Robbers.
36, numbers, A through, no, 6 through 34 even. Honors. 10 through 34 even. And, oh yeah, 46 and 48. Same number. Due Thursday, get to work. You have a test Wednesday, scheduled, tentative.
Looks like fun. By that I mean the math. Like,
Ooh, I'm challenging honors. Challenging.